In this video, we'll explore DeepSeek LLM models and what makes them stand out. We'll then deploy a DeepSeek LLM model using SageMaker and run inference. Hi, my name is Chandralingam. I'm a security and AWS ML engineer. At the core of DeepSeek's advancements is DeepSeek V3, a large language model with 671 billion parameters. According to DeepSeek, this model performance rivals or even surpasses popular models such as GPT-4o and Claude Sonnet 3.5. What makes DeepSeek unique is the architecture. It uses an architecture called as a mixture of experts. DeepSeek is not a single monolith model with 671 billion parameters. Instead, it consists of multiple smaller expert models. This approach is called as a mixture of experts architecture. How does V3 decide which of these experts to use for inference? In fact, it employs a smaller load balancer model that analyzes the input query and then determines which of these experts are best suited for answering that particular query. For example, if you ask a question, what is the tallest mountain in the world? It's not efficient to send this query to all the experts. Instead, the load balancer model routes to a geography expert. Similarly, if you query about a coding exercise, like Python coding challenge or something, that query will be routed to a model that is expert in coding. This dynamic routing approach makes the inference much faster and efficient because the query is routed only to the most relevant parts of the model. In fact, if you look at the activated params in this table, it shows how many parameters are actually used for inference. In case of V3, which is a 600 plus billion parameter model, on an average, it uses only 37 billion parameters to respond to a query. On the other hand, a large model like Llama 3, which is a 400 billion parameter model, it's a dense model, so it uses all 400 billion parameters to answer every single query. Because of this architectural difference, DeepSeek claims that V3 will be more efficient and faster when answering queries. The second major improvement is the use of 8-bit floating point numbers for parameters. Traditional models use 32-bit floating point numbers for storing parameter weights. But what DeepSeek has shown is that they can achieve impressive results by just using 8-bit low-precision floating point numbers. In practical terms, what this means is that for a given number of parameters, DeepSeek model uses 4 times less memory when compared to a traditional model. The multi-rate latent attention is another key innovation that drives down inference costs. It has reduced the cache requirement by over 90% when answering queries. Now, another difference is that DeepSeek V3 can predict multiple tokens that come in a sequence. Traditional models like GPT and Llama, they predict the next token in a sequence. So they predict one token at a time. Whereas DeepSeek V3 can predict multiple tokens that come in a sequence. And DeepSeek claims that this has proven beneficial for model performance. While DeepSeek version 3 grabbed some attention, the real excitement came with the release of DeepSeek R1 model. DeepSeek took the V3 foundation model and added a second stage reinforcement learning layer to improve the model further. This addition led to a significant boost in performance, with DeepSeek R1 matching the performance of OpenAI's latest O1 model in math, coding, and reasoning tasks. The fact that DeepSeek caught up with one of the most sophisticated models from OpenAI using far less resources caught the world by surprise. And this is what led the panic selling of tech stocks. Because DeepSeek demonstrated that algorithmic improvements can deliver much better scaling than just throwing more powerful compute. In fact, DeepSeek R1 is also a 671 billion parameter model with 37 billion activated params. However, this model is also too large for many of the organizations and researchers to try them locally. To cater to this segment, DeepSeek also open sourced several distilled models. Model distillation is a process where you transfer the learning from a large teacher model to a student model so that the student model retains much of the capabilities of the larger teacher model. Think of it like learning tennis with the help of a coach. The coach can quickly pinpoint mistakes and teach you proper techniques, thereby helping you learn tennis faster. Same thing applies with the distillation, where the large model trains the smaller model on how to correct mistakes and retain many of its characteristics. Now, what is interesting is for distillation, for training the smaller models, DeepSeek used many popular open source models from Meta and Alibaba to do this distillation process. So, for instance, if you look at this model, this is a distilled version of a Llama 8 billion parameter model that has absorbed the knowledge of DeepSeek R1. Since this is a much smaller model when compared to 670 billion parameter model, this is much more affordable and easy to try out locally for enterprises and individuals like us. Now, these small models, 1.5 billion and 7 billion distilled models, are ideal for edge devices where you have well-defined use cases and don't need advanced reasoning capabilities. These mid-sized models provide a good balance between performance and cost. You can use these models and fine-tune for domain-specific tasks. And these larger models are in turn useful for more advanced capabilities that you may need. Now, there are a lot of speculation about the origin of these models and whether you can trust them and so forth. But in reality, what has happened is that these very capable and open source model has put a lot of pressure and provides a solid alternative to proprietary models that are coming out of OpenAI, Anthropic, and Google. We are free to download these models locally and try them and customize them and use for real world applications. So the net effect is that these foundation models are getting commoditized and we are going to witness a significant drop in pricing. With this, we are going to move to the next step where we are going to take this Llama 8 billion parameter models and host them in SageMaker and run some inference. Now, hosting this model is fairly straightforward in SageMaker. In fact, the instructions are right there in Hugging Face website. So let's go and check it out. So I selected Distill Llama 8 billion parameter version. And if you go into the deploy option, we can choose the provider where we want to host this model. So let's pick SageMaker. And there it is. So this deployment is done using SageMaker SDK. So SageMaker has a Hugging Face concrete class implementation. So it's fairly straightforward to deploy models that are available through Hugging Face. So the core logic is here. This is the configuration where we specify what type of model we want to deploy. And in this case, we are referring to DeepSeek R1 distilled Llama 8 billion parameter model. And then all you have to do is create an instance of the model and then deploy the model. So one thing to note is when you're deploying, you need a GPU compatible instance. In this case, the code recommends using G5 2x large instance. And if this is the first time you're working with SageMaker Notebook and so forth, you might run into quota limits to check quota whether your account has permission to spin up an instance of this type for endpoints. I'll show you how to check for the quota limits for this one. And then after you deploy the model, you simply call the predict call and provide your input question for which you want the LLM to respond back. And the important point to note is that after you're done with this testing, you have to terminate the endpoint that you deployed because there is an hourly charge for it. So for instance, G5 2x large accumulates approximately $1, $1.50 or so. So I have the pricing page open here. So the recommended instance is G5 2x large. It comes with 1 GPU with 24 GB of RAM, GPU memory. And it also comes with 8 CPUs and 32 GB of memory. So the pricing for this instance type is $1.20. Now, you can also go for this one, G5 extra large instance. It also has the same GPU configuration. Only difference is that number of CPUs and memory is half of this. And there is not much difference in pricing either. So we can try this instance, G5 2x large. Now I'm already logged into my AWS account and I have a Jupyter Lab instance up and running. If you need help on how to set up this SageMaker Studio and launch a Jupyter Lab instance, I have a separate video for that and I've linked it in the description. It's a short video. Now, as I mentioned, we need to first check the quota limits. So from your AWS homepage, search for quota and click on this quota increased request. And for services, look for SageMaker. And there are bazillion quota limits that you can go and look and update. But we are interested in only one thing. ML G5 instance dot 2x large. Now, there are separate quota limits applicable depending on where you want to use this instance, whether you want to use it for training or for endpoint or for notebook and so forth. So you have to pick an appropriate choice when you are checking for quota, and if you need to increase the quota limit, you have to exactly specify for what purpose. So in our case, we are going to use it for endpoint usage. My account already has the quota limit of 2 applied because yesterday I did request for an increase. So usually that request can be, sometimes I've seen 15-minute turnaround time, or sometimes it may take a day, or they may come back and ask some questions and so forth. I think it depends on your usage history. You can also use the G5 extra large instance if you like. If you see a 0 here or 0 here, then you won't be able to deploy the model. You need to request for a quota limit increase. The way to do that is select this instance type and request, or you can just click on this. Follow the prompt for requesting increase at account level. And it's fairly straightforward. It'll take literally 2 minutes to submit the request. You need to go back and check the quota service request history to see if they have updated your quota limits. Now let's go back to our notebook. So let's import these libraries. It went through, and then let's get this role. These are needed for deploying the model. And let's configure the model that we want to deploy. 8 billion parameter distilled version llama. And then create the model. And we get an error. Unsupported Hugging Face LLM version 3.01. What are we doing here? 3.01. Okay. So you may need to upgrade your SDK version, SageMaker SDK. So the current version of SageMaker installed in this notebook supports up to 2.2, whereas we need the 3.01 version. Copy this and take it to the top. Add a cell above it. And there are some dependency related error, auto glue on. We are not going to use all this, so we can safely ignore all this. And it has updated the packages. So we can go ahead with our testing. But before you do that, you have to restart the kernel. So let's restart the kernel here. Okay, fully initialize. Kernel is ready. Let's import again. So you have to re-import everything and execute all these steps again. Now the model was created. It's not yet deployed. Do one more step to deploy the model. So this is where we are actually asking SageMaker to deploy the Hugging Face model on an MLG5 2x large instance. And number of instance count is 1. So if you specify more than 1, it will get automatically load balanced. So for now, 1 is sufficient for us. Let's go ahead and deploy it. So this step may take a few minutes, maybe 2 to 5 minutes. Now, as we wait for the endpoint to be ready, I want to also quickly review the usage recommendation for running the model locally. So what they are suggesting is that they're asking us to use the temperature value between 0.5 and 0.7. Specifically, 0.6 is recommended to prevent endless repetitions or incoherent outputs. Now, sometimes when the temperature value is set too high, the model can generate very creative output. It may not be very relevant for us, so it's better to follow their recommendation. So we'll set it at 0.6. And then they are specifically asking us to avoid adding a system prompt. I don't know why, but they are suggesting all instructions should be contained within the user prompt. So system prompt is used for initializing the LLM to a specific state. So for example, if you are working on a math problem and if you want the LLM to explain to you as if you are a 5-year-old, then in the system prompt, you can say that assume you are a 5-year-old and answer this question. And then in the user input, you actually provide the question. Then the LLM will explain as if you are a 5-year-old. That is a typical use of things like system prompt. So here they are not asking you to use a system prompt. Instead, embed all the instructions in the input and provide it in one shot. And if you're working on mathematical problems, they are also asking you to add the specific instructions if you prefer a step-by-step explanation. And then if you're especially interested in model performance evaluation, don't just depend on one test. Conduct tests with a variety of inputs and average the results. So fairly straightforward recommendation, nothing fancy. So we can easily follow these tips and test our LLM deployment. Okay, the model is deployed successfully. So this is what we want to see. Now we can run some inference. So the syntax for that is, so let me copy this. So predictor.predict, and then the question goes inside the input parameter. And you can also pass additional parameters like temperature, max length, and so forth. Okay, let's ask a question. What is the tallest mountain in the world? Here is our response. It's not very friendly to read right now. It's dumping the entire output here. So let's take the output and process it a little bit, clean it a little bit, and then present it nicely. Answer is this. Let's store it in a variable and do some post-processing. Let's look at the structure of the response. So it's a list with a dictionary inside it. So let's see what the first value in the list is. And that's our answer. And it's inside generated text. So let's just get that. Okay. And if I print it, now it looks a lot cleaner. But let's define a utility function real quick. We don't have to repeat all these steps every time. So what we'll do is we will define a function QA with DeepSeek. We provide the question and parameters, optional parameters that we want to send in. And if we don't have any parameters, then we will set it to temperature 2.6. And that's pretty much it. So we'll just set the temperature for now. And then we need to construct our payload. So we need to construct our payload like this. So let me take this. Input is going to be whatever question you are passing this function. And then for parameters, we are going to set our temperature parameter. And then our answer is going to be predictor.predict and provide the payload. And we are going to return the generated text for the first answer. Okay. Now let's test our method, QA with DeepSeek. We'll ask the same question. What is the tallest mountain in the world? And I'm getting an error. Failed to deserialize the JSON body into target type. What mistake am I making here? Let me just return the payload and see what I get back. Okay, so why is input looks okay, but why is parameters none? Oh, if parameters is none, then I have to set the parameters. If there is no temperature value specified, we are going to set a default to 0.6 and then set the parameters. So hopefully this should fix the problem. Let's try now. Now this looks much better. So however, the formatting is still not good. So let's store the response in a variable and print it. Print response. Let me rerun this again. And here is our response. The response is changing for every time we ask the question. So what is the tallest mountain in the world? Everest, K2, and so forth. And it's providing some explanation on how it's approaching it. So it is getting a little bit creative. It's not returning very precise answer. So we had to fine tune some parameters to get it to precisely answer what we want. Maybe lower the temperature value to 0.5 and see what it does. In fact, it correctly answered as Mount Everest. And then it went on to explain the local name in Nepal is Sagarmatha, and provided some nice description. So there you have it. So this is how you can very quickly deploy your DeepSeek model on SageMaker. And before we wrap up, I had to tell you one important thing. We had to delete the endpoint, because if you go into SageMaker Studio and if you go and check the endpoints, you'll see that this endpoint is currently in service, and that means this is currently accumulating a charge. So you can come here and delete it, select the endpoint and delete it, or you could also do it through programmatically. So all you have to do is predictor dot delete endpoint, and that will almost immediately delete the endpoint and stop the billing for you. Let's cross check here. There are no endpoints running here, so we are good here. And one final thing is that you have to also stop the Jupyter Lab instance to prevent any charges, hourly charges. So that is this notebook where we deploy the model and interacted with the model. So you have to also stop this instance. Hope you like this video, and reach out to me if you have any questions, and happy learning.